Welcome to Ask and Learn.
So in this problem, we're going to see Jake running on a moving train flat car, and we're going to rank the magnitude of the momenta from greatest to smallest. On part A, we're going to do this ranking relative to an observer on the flat car, and on part B, we're going to do it relative to a stationary observer on the ground. So let's start with part A, and let's call the momentum for situation 1 momentum 1A over here, and we're going to say that the positive side is pointing towards the right. So let's start with momentum 1A over here. We see that Jake is running to the left, so he has a negative velocity. Therefore, for an observer on the flat car, all that he sees on Jake is his velocity toward his 4 meters per second velocity. Therefore, the magnitude that he's observing is minus 4 mj. Since the formula for the momentum is mass times velocity. So mj is mass of Jake, and velocity is minus 4. For situation 2, we're going to do momentum 2a, and we see that Jake is moving towards the right, which is the positive side. So he has a 6 meters per second velocity. Therefore, the momentum is going to be 6 mj. So 6 times, which is the velocity, times the mass of Jake. On part 3, he's again moving towards the right, so the velocity is positive once again. So the momentum here, momentum 3a, is going to be 4 meters per second towards the right, times the mass of Jake, 4 mj. And then on the last case over here, we have Jake moving towards the left at 6 meters per second. So since he's moving towards the left, the velocity is negative. The momentum is going to be momentum for A is going to be the mass of Jake times minus 6 meters per second minus 6 mj. So now let's do a ranking over here for part A. We have the biggest momentum is for 2A, which is 6 times the mass of Jake. But since we care only about the magnitude of the momenta, we're going to say that for part 2A and for part 4A, we have the same magnitude, which is 6 mj. So we have 2A is equal to 4A. And then these two are both going to be greater than the 4 mj magnitude for part 1 and 3. So bigger than 1A, which is equal to 3A. Now for part B, we're going to see a relative to the stationary observer on the ground. So the stationary observer over here, he's going to see Jake moving to the left at 4 meters per second, but the car is moving to the right at 8 meters per second. So from his point of view, he's going to see Jake moving towards the right at 4 meters per second. Since it's the 8 meters per second moving towards the right, subtracted by the 4 meters per second of Jake moving to the left. So then we get momentum one B is going to be equal to, so 8 to the right 4 to the left, 8 minus 4, we get 4. So positive 4 mj. Here on part 2, we write the momentum 2b. The observer is going to see Jake moving towards the right at 6 meters per second and the cart moving towards the left at 10 meters per second. The speed that he's going to see Jake is going to be the 6 on the positive side and 10 on the negative side. So it's 6 plus minus 10, which is equal to minus 4. Therefore, his momentum is minus 4 mj. Then on part 3, the momentum 3b is going to be equal to, so in this case, we have Jake moving towards the right, which is the positive side at 4 meters per second, and the cart is also on the positive side at 6 meters per second. Therefore, the final velocity of someone watching from the outside is going to see Jake moving at 6 meters per second plus 10 meters per second, with a total of 10 meters per second. Therefore, they're both on the positive, then 10 mj is the momentum for this part B on the situation 3. So now situation 4, we have the cart moving at 18 meters per second towards the positive side or to the right side, and Jake moving at 6 meters per second towards the left side. So 18 meters per second towards the positive plus minus 6 meters per second, since it's towards the negative, we're going to get positive 12. So the momentum for B is going to be equal to 12 mj. Now we're going to write it over here. The biggest momentum that we got is this 12 on part 4a. So 4a. And then the second one is 10. So 4a is bigger than, part 3. Oh, it's not 8. It's b. So 4b bigger than 3b, which is 10. And then we have 4 and 4. Then 3b is bigger than both of those. So part 1a is equal to 2a, and they're both smaller than 3b. So let's just write our formulas over here once again. We have on part A, since we only care about the observer, our momentum is always going to be the mass of Jake multiplied by the velocity of Jake. And we have to remember that this is a vector. Therefore, if it's going towards the right, it's going to be positive, and towards the left, it's going to be negative. For part B, it's mass of Jake once again, and then we multiply that by Jake's velocity summed with the cart's velocity. Once again, let's remember that this is a vector addition, therefore the direction matters, and we are going to use positive if it's going towards the right and negative if it's going towards the left.